Look at Mars, a frozen, irradiated, endless desert. It looks like the ultimate graveyard of the solar system, where nothing could possibly survive. But before you declare the red planet completely dead, you need to look closer to home, because Earth hides a shocking secret. Welcome to the extremes of our own world. Places so completely barren, so brutally hostile, that they shouldn't support life at all. Yet, NASA sends their most advanced rovers here, not to study Earth, but to use these deadly wastelands as a cosmic training ground. Why? Because if you want to find alien life surviving in the harsh dirt of Mars, you must first understand the impossible survivors on Earth. Scientists call them extremophiles. These are microscopic monsters that laugh in the face of deadly radiation, boiling acid, and absolute freezing darkness. They don't need lush forests or deep oceans. They have rewritten the very rules of biology, proving that life is far more stubborn than we ever imagined. For decades, we searched the Martian surface for obvious signs of biology. We looked for ancient lakes, green patches, or moving shadows. We found ancient riverbeds, yes, the ghosts of water that flowed billions of years ago. But the surface today is a toxic, dry hellscape. The ultraviolet radiation from the sun constantly blasts the Martian ground. Any normal organic material would be instantly shredded into microscopic pieces. So our robotic explorers had to change their strategy. They stopped looking for life on the surface and started looking exactly where Earth's toughest creatures hide, beneath the surface, inside the rocks, protected by a crust of minerals hiding from the lethal cosmic rays that bombard the planetary crust. It is a game of cosmic hide-and-seek. To win it, we are traveling to the driest, most Mars-like location on our entire planet, a place where rain hasn't fallen for centuries. A desert so hyper-arid that even organic decay simply stops dead in its tracks. We are heading into the unforgiving heart of the Atacama Desert. Prepare yourself, because we are about to meet Earth's very own alien residents. Welcome to the Atacama Desert in Chile. It is officially the driest, non-polar place on Earth. Some weather stations here have never recorded a single drop of rain. The ground is baked by intense ultraviolet radiation from the sun. The soil is rich in toxic perchlorates, the exact same chemicals that poison the surface of Mars. If you walk through this hyper-arid core, you will find no plants, no insects, and absolutely no animals. It feels completely and utterly dead. That is exactly why NASA brings their Mars rovers here. If a robot can navigate and dig through the Atacama, it is ready for the red planet. But we are not just testing wheels and cameras. We are hunting for something incredible. We are hunting for biological miracles that refuse to die. Our geologist and the rover begin scanning a seemingly lifeless patch of salt crust. To the naked eye, there is absolutely nothing but dry, cracked minerals. But salt can do something extraordinary. Certain salt crystals can actually absorb moisture directly from the thin atmosphere, a process called deliquescence. Inside these tiny, salty pockets of liquid, a hidden world awakens. Extremophile bacteria have adapted to live their entire lives trapped inside the salt. They enter a deep state of suspended animation when the air is bone dry. But the moment the salt pulls in a micro drop of water, they reactivate. This is a critical lesson for astrobiology. We realize that life does not need an entire ocean to survive. It just needs a microscopic oasis. If Earth bacteria can wait patiently inside salt crystals for a tiny drink of atmospheric water, could Martian microbes be doing the exact same thing right now? Deep beneath the Martian dust, there are identical salt deposits. The chemistry matches perfectly. The physics matches perfectly. The only missing piece of the puzzle is biology. The Atacama proves that extreme drought and toxic soil are not a death sentence. Life simply retreats. It builds an armor of stone and salt. But salt is not the only fortress these extremophiles use to protect themselves from the deadly radiation raining down from the sky. In the next phase, we will crack open solid rocks to reveal the ultimate masters of cosmic hide-and-seek. The endoliths are waiting in the dark. When you crack open a translucent quartz rock in the Atacama, you don't find dust. You find a distinct glowing green line just millimeters beneath the surface. These are endoliths, literally the stone dwellers. To escape the deadly UV radiation and the brutal heat, these microbes simply migrated inside solid rock. The rock acts as a perfect biological bunker. It physically blocks the lethal ultraviolet rays while trapping tiny amounts of precious moisture inside its microscopic pores. But they still need energy. By choosing translucent crystals like quartz or salt, the rock acts like a greenhouse window, filtering safe sunlight down to the colony. While the surface of the desert burns at 50 degrees Celsius, this hidden micro-world remains cool, humid, and actively photosynthesizing. A secret oasis inside a stone. This discovery fundamentally changed how NASA programs its rovers. It taught us that looking at the dusty surface of a dead planet is practically a waste of time. On Mars, the surface dirt has been bombarded by cosmic radiation for billions of years. Any organic molecules resting on the top layer are completely eradicated. But if you go just 1 centimeter deep, the story changes. The Martian rock itself serves as a radiation shield, exactly like the quartz in the Atacama. Ancient Martian riverbeds are packed with sulfate minerals like gypsum. These stones are light-transmitting fortresses, capable of preserving biological signatures for eons. This is precisely why modern rovers are equipped with heavy drills. They don't just scoop the red dirt, they physically crack open the rocks to look inside. Inside these drill holes, we are searching for the ultimate prize. We are looking for chemical remnants, isotopic ratios, or even fossilized trails left by Martian endoliths. If life ever existed on the red planet, its last survivors probably retreated into the rocks as the atmosphere thinned and the oceans boiled away into space. The stone became their final refuge, a silent, frozen tomb that might still hold the microscopic fossils of an ancient alien biosphere waiting to be discovered. So, the Atacama taught us that life can survive extreme heat and drought by hiding underground. But what happens when you remove the heat entirely? Let's leave the blazing desert behind. It is time to travel to the coldest, darkest, and most alien continent on our planet, the frozen McMurdo Dry Valleys. Welcome to Antarctica. But wait, where is the snow? You are looking at the McMurdo Dry Valleys, one of the most bizarre landscapes on Earth. Here, massive katabatic winds rip down the mountains at hurricane speeds. They instantly evaporate any ice or snow, leaving behind a frozen, barren wasteland. The temperature here plummets to minus 60 degrees Celsius. It is dry, dark, and utterly freezing. It is the absolute closest earthly match to Mars. Mars is not just a desert, it is a freezing desert. The average surface temperature is roughly minus 65 degrees, exactly like the dry valleys. Our robotic companion struggles against the biting wind. The ground is hard as iron, locked in permafrost that hasn't completely thawed for millions of years. In this environment, you would think absolutely nothing could survive. Any living cell would freeze instantly, its internal water turning into deadly ice crystals. But biology always finds a loophole. Deep inside the porous sandstone rocks, we find the familiar green line of cryptoendoliths, the cold weather survival experts. To prevent freezing to death, these microbes produce their own natural antifreeze, special proteins that stop ice crystals from shredding their delicate cellular walls. During the pitch-black Antarctic winter, they completely shut down. They stop growing. They stop eating. They simply freeze in time, waiting for the light. And when summer briefly arrives, warming the rock just enough to melt microscopic layers of frost, they drink, photosynthesize, and slowly repair their DNA. This cycle of deep freeze and brief awakening has massive implications for Mars. Because Mars is loaded with subsurface ice near its polar regions, could Martian life exist in a state of deep freeze right now? Locked in the ice, waiting patiently for the global climate to shift once more. This theory has driven NASA to plan future rover missions closer to the Martian poles, equipped with heated drills designed to safely pierce the permafrost. The Atacama taught us that life beats the drought. McMurdo proves that life beats the ultimate freeze. But there is one more deadly obstacle. Deep beneath this frozen valley, lies a buried secret. A subterranean lake so completely saturated with salt that it bleeds bright red into the ice. Staining the pristine white glacier of the dry valleys is a terrifying sight. It looks exactly like a waterfall of dark, freezing blood. Scientists appropriately named it Blood Falls. But this is not blood. It is ancient, iron-rich water reacting violently with oxygen as it hits the surface. The real mystery lies beneath the ice. For 2 million years, a massive subglacial lake has been completely sealed off from sunlight and fresh air. How does it stay liquid in the freezing Antarctic underground? The answer is salt. The water is so hypersaline that it simply cannot physically freeze. Trapped in this pitch-black, super-salty underground ocean, you would expect absolute sterility. Instead, scientists discovered a completely thriving ecosystem of extremely resilient bacteria. Without sunlight for photosynthesis or oxygen to breathe, these biological wizards do the impossible. They survive by literally breathing dissolved iron and sulfate compounds. This completely shattered our understanding of habitability. It proves that life does not need a warm, sunlit ocean. It just needs liquid water. And that brings us straight back to the frozen wastelands of the red planet. For a long time, we thought Mars was completely bone dry, but ground-penetrating radar from orbiting satellites revealed a shocking anomaly deep beneath the Martian southern polar ice cap. A highly reflective layer, massive subglacial lakes of toxic, freezing brine completely hidden underground. They are the exact extraterrestrial twin of Earth's bizarre and terrifying Blood Falls. This is where our rovers are desperate to go. If we can drill deep enough into these Martian brines, what might we actually find? Could there be an independent genesis of life, blindly breathing iron in the freezing dark, totally unaware of the vast universe above? Drought, extreme cold, and toxic salt. Earth's deadliest environments have shown us that biology possesses an absolutely unbelievable toolkit for universal survival. But there is one final boss in this cosmic game. The ultimate killer that sterilizes entire planets and destroys DNA on contact. Cosmic radiation. Can biology survive a direct hit from lethal gamma rays? In the next phase, we meet the mutant bacteria that eats radiation for breakfast. Mars has no thick atmosphere and no magnetic field. The surface is constantly bombarded by solar flares and deep space cosmic radiation. To any normal biological cell, radiation is the ultimate killer. It acts like microscopic shrapnel, violently tearing apart the delicate strands of DNA. But meet the undisputed champion of the microscopic world. Scientists lovingly call it Conan the Bacterium. Its real name is Deinococcus radiodurans. If you blast a human cell with 5 units of radiation, it dies. Conan can survive an astonishing 10,000 units without flinching. When high-energy gamma rays strike this bacteria, its DNA is completely shattered into hundreds of broken fragments. It should be instantly dead. But Conan possesses an impossible superpower. Within hours, a specialized protein ring grabs the broken DNA fragments and flawlessly stitches them back together. It is like putting a million-piece puzzle into a blender, hitting blend, and watching the puzzle perfectly reassemble itself in record time. This extraordinary radiation resistance changes everything we thought we knew about Mars. It completely redefines the expiration date of Martian life. Even if Mars has been utterly dead for millions of years, an organism like Conan could simply be resting in a dormant state, trapped within the permafrost, shielded by just a few meters of rock. These biological survivors can take cosmic hits and simply repair themselves. We are no longer just looking for the fossilized remains of ancient biology. We might actually be looking for sleeping giants. Extremophiles wait for an event, a meteorite impact or a geothermal shift that might briefly melt the ice, allowing them to wake up and reproduce. This completely justifies why NASA invests billions into the Perseverance rover. We are not digging up a graveyard, we are searching a bunker. From the dry Atacama to the freezing Antarctic and the mutant radiation eaters, Earth has provided the ultimate treasure map for Mars. Now it is time to put this map to the test. In the next phase, we follow the ultimate hunters, curiosity and perseverance. We have the ultimate treasure map from Earth. Now we are using it. Welcome to Jezero Crater, an ancient, dried-up Martian lakebed. Billions of years ago, this crater was overflowing with liquid water. Today, it is a freezing, irradiated bowl of dust and jagged rocks. Enter NASA's most advanced robotic hunter. It isn't just taking pretty pictures. It is actively searching for the Martian equivalent of Conan. We are not scooping the dead surface dirt. Following the lessons of the Atacama, the rover drives straight toward the ancient sediment layers. These layered rocks are the perfect biological bunkers. If endoliths ever existed on Mars, their fossilized remains would be trapped right inside here. The rover extends its robotic arm and deploys a heavy rotary drill. It bites into the rock, completely bypassing the sterilized, irradiated top layer. Dust flies as the drill penetrates deep into the protective crust. It extracts a perfect, cylindrical core sample of the ancient Martian geology. Inside that tiny rock core could be the greatest discovery in human history. Chemical signatures, isotopic ratios, or even microscopic petrified cells. We use lasers and ultraviolet spectrometers to deeply scan the fresh rock interior. We are hunting for glowing biological molecules hiding in the dark. The rover analyzes the sample, looking for the exact same carbon-based molecular structures we found inside the frozen stones of the Antarctic dry valleys. But the rover is not just analyzing these samples on the spot. It is carefully sealing them inside ultra-clean titanium tubes for the future. These pristine tubes are being dropped across the Martian surface, building a cache of rock cores. It is a cosmic breadcrumb trail of evidence. In the coming decade, a daring new mission will fly to Mars, pick up these exact tubes, and blast them back to our Earth. For the very first time, human scientists will study pristine pieces of another planet inside our most advanced, high-tech biological laboratories. The rocks of Jezero are already waiting for their ticket home. But what if we find something that is not just a dead fossil? When those titanium tubes finally arrive on Earth, they will be opened in the most secure, highly sterile laboratories ever built by human hands. Scientists will look for the exact same biological survival mechanisms we discovered in the Atacama Desert and the freezing McMurdo dry valleys. If we find even a single fossilized microbe or a dormant cell, it fundamentally changes our entire understanding of the universe. It would absolutely prove that life is not a miraculous accident, completely unique to Earth. It would mean that biology is a universal constant. If extremophiles can survive the radioactive hell of Mars, they could easily thrive in the dark, warm subglacial oceans of Europa or Enceladus. Our robotic explorers have proven that the universe is not just a collection of dead rocks. It is a vast, interconnected, and dynamic laboratory. Earth's deadliest places taught us exactly how to look, where to look, and most importantly, how to respect the unimaginable resilience of life. From the sun-blasted, toxic salt crusts of the Atacama Desert to the freezing, bleeding iron glaciers of the remote Antarctic dry valleys, to the frozen, irradiated, endless plains of the Red Planet. The playbook of biological survival has been written in the stones, and somewhere, deep beneath the alien dust, a microscopic survivor might just be waiting patiently for the ice to melt once more. The rocks of Jezero Crater have kept their incredible secret for 3 billion years. But their time in the shadows is finally up. The search for alien life has never been closer to a breakthrough. We just had to learn how to survive our own planet first. What do you think? Will we find dormant extremophiles hiding in the rocks of Mars? Or are we completely alone in the void? Let us know your thoughts in the comments below. If you want to join us on the next cosmic journey, hit that subscribe button. This is just the beginning of our universal exploration. Stay curious, keep looking up, and we will see you in the next adventure.